This video is going to walk you through how to manipulate some of your trigonometric identities and how to simplify some trigonometric expressions. So I have our identities up here already, our reciprocal, quotient, Pythagorean, and negative. And these are the ones that we're going to be using today in this video. All right, so let's talk about manipulating your identities. I've written 4 identities up here, and when I say manipulate them, we don't have to always think of our identities in the form that we're given them in the book. They come in many, many, many different forms. So for instance, say I have the form tangent of theta equals sine of theta over cosine of theta. That's what the book gives us. But I can also square both sides and get the tangent squared theta equals sine squared theta over cosine squared theta. Okay, so if I square both sides of this identity, I get something that looks similar but is a little bit different. I can also cross multiply and get cosine of theta times tangent of theta equals sine of theta. Okay, so I can use all of my algebraic properties to manipulate our original identity. So I can also get cosine of theta equals sine of theta over tangent of theta. So there's a million different things that I could do. All right, so what could we also do for this one right here? Well, I can square both sides again. Sine squared theta equals 1 over cosecant squared of theta. I can cross multiply and get sine of theta cosecant of theta equals 1. I can get cosecant of theta equals 1 divided by the sine of theta. And I can continue and continue and continue with manipulating that as well. So what can we do with some of our Pythagorean identities? Well, I can add and subtract. So if I said sine squared theta equals 1 minus cosine squared theta, right? I can think of that identity in this form. I can also say cosine squared theta equals 1 minus sine squared theta and think of it in that form. So these are just different forms of the same identity. How about if I said, tried to use this identity down here, tangent squared plus 1 equals secant squared plus 1. Well, I could subtract tangent squared to the other side and get secant squared theta equals, 1 equals secant squared theta minus tangent squared theta. I could also switch these guys and say tangent squared theta minus secant squared theta equals -1. Okay, so I can also say 1 minus secant squared theta equals negative tangent squared theta. All right, so there's a whole bunch of different ways that we can start thinking about our identities. We don't always have to think about them in the form that they were given. So this exercise that you will be completing today makes you think of these identities in their alternate forms. So I'm going to go through a whole bunch of examples from number 60 to number 80. Just going to do the even ones since you have the odd ones for homework. The instructions here are to go ahead and write all of your trigonometric identities in terms of sine and cosine first. Then you're going to simplify, leaving no quotients. So they're odd instructions, so watch how I do these examples and then you'll understand what the instructions really mean. So the very first thing they say is write your trigonometric functions in terms of sine and cosine. Well, this one's already in terms of cosine, so we're going to rewrite tangent in terms of sine and cosine. And from the quotient identity, I know that tangent is sine over cosine. And now we can clearly see that our cosines reduce out and this expression really equals the sine of theta. All right, number 62, we're going to do the same thing. We're just going to go ahead and write everything in terms of sine and cosine, and you can see here that cosine is already done. So what is cosecant? Cosecant is 1 over the sine of theta times cosine of theta. And what is tangent? Tangent is sine of theta over cosine of theta. So you can clearly see that our sines will reduce out, our cosines will reduce out, and this expression ultimately equals the number 1. Number 64, let's go ahead and write secant of theta in terms of sine and cosine. So I know that that is 1 over cosine of theta. And you can see here that nothing reduces. So I'm just going to multiply these two quantities to get sine over cosine. All right, so the second part of the instructions were to not allow any quotients in our final answer. Well, I have a quotient here, right? A fraction is a quotient, right? This is a quotient. So what I'm going to do is I'm going to go back to my identities and see if I can find something that equals sine over cosine. And when I do that, I realize that tangent of theta equals sine over cosine. So this expression here ultimately equals tangent of theta. So number 66, we can use all of our algebraic methods to simplify expressions. So one of the things that we can do in algebra is distribute. Well, we can distribute here as well. So before I rewrite everything in terms of sine and cosine, I'm going to go ahead and distribute. All right, so now I'm going to go ahead and write everything in terms of sine and cosine. So I know cotangent squared is cosine squared over sine squared, right? And I know that because cotangent of theta is cosine over sine. And when I square both sides, I get this. All right, so I can replace that with cosine squared over sine squared. So I'm going to do the same thing here. And I'm replacing tangent squared with sine squared over cosine squared. And you can clearly see that my cosine squareds and my sine squareds are going to reduce out to the number 1. So now I have cosine squared theta over sine squared theta plus 1. Not allowed to have quotients in my answers, so I'm going to just convert this back to cotangent squared theta plus 1. And if I really go back into my trigonometric identities, I know I have that identity 1 plus cotangent squared of theta equals cosecant squared theta. I know that cotangent squared theta plus 1 equals cosecant squared theta. So this expression up here ultimately equals cosecant squared of theta. All right, so now I have number 68, and I like this one because this one is just foiling, right? We're going to distribute this first term and the second term across the two terms in my second expression. So I get secant squared of theta plus secant of theta minus secant of theta minus 1. These will reduce out to give me secant squared of theta minus 1. And I know they said to go ahead and convert to sine and cosine, but for this, I'm not even going to convert. I'm going to take a look at, I have that Pythagorean identity where it was tangent squared of theta plus 1 equals secant squared of theta. I'm going to see if I can manipulate that to get a secant squared of theta minus 1. And I clearly see that if I subtract the 1 from both sides of this expression, I get secant squared theta minus 1. So this expression really equals tangent squared of theta. So our original expression that looked pretty complicated really equals tangent squared of theta. So here's number 70. Okay, so let's go ahead and for number 70, let's follow the instructions and write everything in terms of sine and cosine. Cosine, sine, cosine over sine. Well, what do you think we could do here? Well, let's go ahead and let's get rid of our sine. Let's multiply, this is a complex fraction. Let's multiply the numerator and the denominator by sine of theta. So remember, I have to distribute. So I'll get the sine of theta plus, now when I multiply these two, this times this, the sine of theta will reduce out. Okay, so now when I multiply the denominator, that will reduce out. All right, so it says I'm not allowed to have any quotients. So I'm going to split this fraction up into two fractions. Right? Both of these are being divided by the cosine of theta. And then I know that sine of theta over cosine of theta is tangent of theta. And of course, cosine over cosine is 1. And remember, that is definitely not one of my identities, because my identity is tangent squared of theta plus 1 equals secant squared of theta. This is not squared, so I cannot use a Pythagorean identity to reduce this anymore. Okay, so let's go ahead and walk through this one, and then I'll make a video for the last couple if you want to continue watching. All right, so the very first thing I usually do is I get rid of my negative thetas. So I know that sine squared really means just this. And I know that cotangent squared really means multiplying this twice. So this is where I usually get rid of my negative angles. So I know that my negative angle equals negative sine of positive angle. So I'm going to replace both of these with what it equals. So that's one of my negative angle theorems or properties. And cotangent is the same, right? Cotangent of negative theta is negative cotangent of theta. So now I'm just going to simplify this. When I multiply a negative times a negative, I get a positive. So it's 1 minus sine squared of theta. And this becomes the same thing, 1 plus cotangent squared theta. So now I'm going to go ahead and replace cotangent with our sine over cosine, or cosine over sine. So this is going to be cosine squared of theta over sine squared of theta. And then I'm going to go ahead and find a common denominator here. So I have 1 minus sine squared theta over sine squared theta, sine squared theta, plus cosine squared theta, sine squared theta. And then I'm going to combine that into one fraction, sine squared theta plus cosine squared theta